So this video is dedicated to Ari. Hi Ari. And I want to talk about fractions. Okay, so a lot of people have trouble with fractions. It may be because people are trying to visualize cutting cakes and stuff into pieces so hard. And it might not be easy for everyone. I know that's not that easy for me. But sometimes it is easy for people to visualize cutting cakes, and that's their way of understanding fractions. So for me, a fraction is really just a way of expressing division. So this fraction 5/7 just really means, by definition, 5 divided by 7. And so that sounds pretty easy right now, but I need to clear up a little bit of a difficulty, because I think when you do learn division, you only divide whole numbers. So that's something that I want to get past. So let's say you do 7 divided by 2. Okay, and you're used to writing that's equal to, so 6, a 2 goes to 6 3 times, and then there's 1 left over. So you say that's equal to 3 remainder 1. Okay, and what that really means is we're actually taking 7, we're taking 6 away from 7, and we're dividing it by 2, because 6 divides exactly by 2 3 times. And the one that's left over, we actually just don't do anything with. We don't even carry out the division for that. So we're really just saying 7 equals 6 plus 1. Divide the 6. Then we just leave 1 with nothing done to it, because we don't know what happens. But fractions is perfect, because it says 5 divided by 7, but it doesn't necessarily tell you what happens. It just gives you a way to represent the answer that you get. So it's almost like an unknown, really. 5/7. And you could visualize that as a fraction of a pizza or something, but you don't have to right now. And if you wanted to write this in terms of fractions, what you'd be doing is you'd be writing 7/2 is equal to 3 plus 1/2. And so now you're saying, well, I don't want to just leave the 1 undivided. I want to divide the 1 by 2 as well. Okay, and even though I don't necessarily know what that is, I have a way of representing it. Okay, so this is how I want to define a fraction, and I don't want to represent it on cakes or pizzas till later. And for me, it's actually a really good way to solve problems with cutting pizzas and cakes, because it's really confusing for me how many pieces I have to cut. But if I represent what I want from the problem as fractions and then do the appropriate operations, then I'll get my answer, and then I can visualize the answer directly. So that's my way of around manipulating pizzas and cakes. Okay, so fractions represent a division. That's what I want to get through. And so 5/7. So for example, 5/7 times 7 is something really obvious to do, and it's going to bring forth a point I really want to emphasize, is that because fractions represent division, and divisions are really crucially related to multiplication, this relationship is going to be essential to fractions as well. So 5 divided by 7 times 7 is just equal to 5, because when you divide by something and then times by something, you get back the original thing. And if you times by something and divide it by something, you also get the original thing. Something more obvious maybe is 7 divided by 7, okay, is equal to 1. So that's going to be true no matter what. So for any number divided by itself, you always get 1. So the fraction with the same things in the numerator and denominator, so the top is called the numerator, the bottom is called the denominator. If they're the same number, the answer is always going to be 1. if you times a fraction by whatever numbers in the denominator, you're always going to get just the numerator. Okay, that's kind of what we've shown in general. We've shown for 5 and 7, but I want to extrapolate for all numbers. So we can represent actually every whole number, every number as a fraction. So 5 can be represented as 5 over 1. That's just because anything divided by 1 is just the same. So actually fractions are able to represent all the numbers that you know so far, and all these other non-whole numbers that we don't know yet, but we're trying to understand. And can you see how if we could just understand the ones where the numerator is smaller than the denominator, it'll be enough?